The second type of path analysis that I'm going to cover is called the cross-legged panel design. The purpose of the cross-legged panel design is to gain insight into the direction of causation between two variables. In other words, this method is useful if a researcher is curious whether A leads to B or whether B leads to A. And in a cross-legged panel design, a researcher measures two variables at two different points in time. In other words, the researcher measures variable A at times 1 and 2 and variable B at times 1 and 2. In a cross-legged panel design, a researcher gathers data from the same group of people at 2 points in time, and at each time point, the researcher measures two specific variables. So an example of a cross-legged panel design might be a study in which a researcher gets a sample of people and records each person's income and level of happiness. And then at time 2, at a certain later point in time, the researcher goes back to that same group of people and records their income and happiness at time 2. And in a cross-legged panel design, 6 correlations are calculated. So I mentioned that the two variables are A and B. That's what I'm referring to them as. So in a cross-legged panel design, the researcher calculates the correlation between A and B at time 1, A and B at time 2, A at time 1, and A at time 2, which is basically the correlation between A and itself at 2 different time points, the correlation between B at time 1 and itself at time 2, and also the correlation between A at time 1 and B at time 2, and B at time 1 and A at time 2. And these last two correlations are actually the most important ones, and I'll explain why in just a moment when we get to an example. So I know that this is a lot to take in right now, but I think this will make a lot more sense once we get to a concrete example. I know it might be kind of abstract right now. So here's an example of a cross-legged panel design, or an imaginary example. So imagine a researcher reads an article about a correlational study that showed a positive correlation between income and happiness. In this study, the researcher found that the participants who were earning a higher income tended to also be the happier participants. And imagine that the researcher is curious about two possibilities. The possibility that the people started off with a high income and that led to their happiness, or whether the people were happy at the beginning and the happiness actually caused them to go out and earn a higher income, maybe because of more energy or motivation. So in this situation, the researcher is interested in which direction is actually correct. And the researcher can do a cross-legged panel design to get some insight. So in this study, the researcher would do a survey, and the researcher would get a sample of participants, and the researcher would record the income and happiness level of the participants at time 1, and then let's say 1 year later, the researcher would go back to that same sample and record their income and happiness at time 2, which I'm saying is 1 year later. And the same group, like I said, the same group is completing this survey at the 2 time points. And after gathering the data, the researcher would calculate the 6 correlations we talked about, which in this context would be income and happiness at time 1, income and happiness at time 2, income at time 1, and income at time 2. And the third one is probably going to be a positive correlation because the people who have a high income at time 1 will typically also have a higher income at time 2, a year later. So like I said, number 3 is probably going to be positive. Number 4 will also probably be positive because the people who were happier at time 1 will tend to be the people who are also happier a year later. The researcher will also calculate the correlation between income at time 1 and happiness at time 2. And when the researcher calculates that correlation, the researcher is looking at whether the people with the high incomes at time 1 tend to be the happy people at time 2. And also the researcher will calculate the correlation between happiness at time 1 and income at time 2. And by doing that, the researcher is looking at whether the people who are happier at time 1 tend to also be the higher earners at time 2. And here's the first possible outcome of this cross-legged panel design. The first possible outcome is that the correlation between income at time 1 and happiness at time 2 is statistically significant, but the opposite is not statistically significant. So the correlation between happiness at time 1 and income at time 2 is not statistically significant, which is why there's no arrow right there. So if this is what happens, the researcher would say that the data is consistent with the possibility of income leading to happiness, and it's not consistent with the opposite. That's because if this is what the data is showing, then the data is showing that the people who were high earners at time 1 tended to be happier people at time 2, but the people who were happy at time 1 weren't consistently high-earning people at time 2, which implies that this first path is more consistent with the data. The second possible outcome is the opposite. So if the correlation between happiness at time 1 and income at time 2 is statistically significant, and the opposite is not statistically significant, then the data is consistent with the possibility of, the data is more consistent with the possibility that happiness leads to income. Because if this is what the data is showing, then the data is showing that the people who were happier at time 1 tended to be the higher earning people at time 2, but the people with the high incomes at time 1 weren't consistently happy at time 2. So the data is only showing that the happiness at time 1 is associated with income at time 2, and the opposite is not being shown by the data. The third possibility is that both correlations are statistically significant. So it's possible that the correlation between income at time 1 and happiness at time 2 is statistically significant, and the other correlation between happiness at time 1 and income at time 2 is also statistically significant. And if this is what the data shows, then the data is consistent with both possibilities. In other words, if this is what the researcher finds, then the data is consistent with income leading to happiness, and it's also consistent with happiness leading to income. In other words, the data is consistent with what's called bidirectional causation going in both directions. And this could very well be the truth, because it might be that having a high income leads to happiness, and that having happiness motivates a person to go out and earn an even higher income later on. So it might be kind of like a cycle that kind of like repeats itself. And the fourth possibility is that neither correlation between time 1 and time 2 is significant. So this arrow is not significant, and this other arrow is also not significant. The two diagonal arrows are both not significant. And if this is what happens, then the data is consistent with neither possibility. The data is not consistent with income leading to happiness, and it's also not consistent with happiness leading to income. If this is what the data shows, then the data is actually consistent with a third variable being the cause. So if neither correlation is significant, then the data is actually consistent with a third variable actually causing both income and happiness. And so actually, if I wanted to use a technical term, I would say that the data is consistent with the correlation being spurious. In other words, being driven by some third factor. And so here's a summary of possible outcomes in a cross-legged panel design. If the correlation from A to B, if that diagonal arrow is significant, then the data is consistent with A leading to B. If the diagonal arrow from B to A is significant, the data is consistent with B leading to A, the opposite. If both of the diagonal arrows are significant, then the data is consistent with both possibilities. And if neither diagonal arrow is significant, then the data is simply significant with neither direction, and the data is more consistent with a third variable being the cause. And that's all I wanted to cover for this topic. So just let me know if you have any questions.